are you all? So today I'm here with a new topic which is quite interesting as well, and that is exploratory data analysis. We have gone through with several pandas functions and the methods that how to apply analysis on using pandas on different data set. So we'll be talking about the exploratory data analysis. What actually exploratory data analysis is? We call that EDA in short. So why we need this? I'll be talking about that why we need this and how to use this, and what are the several techniques that we use to perform exploratory data analysis for a given data set. So first, exploratory data analysis is a process, or you can say it's a technique where you can get some insight about the data, and you can get the summary what actually your data says, so that you can get that information and you can utilize that information further to build the machine learning models. So that's just a basic information of exploratory data analysis. Now, what are the several techniques that we use to perform exploratory data analysis? So I have written all the techniques here, and I'll be discussing one by one. First of all, we talk about the handling missing values. Let's say we have a data and we have multiple missing values to that data, and those missing values can be numerical as well and can be categorical as well. So how we deal with this situation? How to handle these missing values? Do we need to drop those columns or records? Do we need to perform some different techniques so that we can fill those values? And in case we need to fill those values, how we will fill those missing records? And from what data you are going to fill that? So next is that was handling missing. I'll explain that in details. Then we move forward to the next technique, which is removing duplicates. Let's say we have lot of duplicacy in our data. So it is really important to remove the duplicate values, otherwise we won't be able to get the clear insight of our data. So how to remove duplicates and how to find out the duplicate values using pandas. Further, there is one of the most important topic, which is outlier treatment. So outlier treatment is also one of the best technique that we apply for EDA, and we need to understand first what actually outlier is. Outlier is any data which performs quite different from the collection of your data. For example, we have multiple records, and let's say they all are linear to each other. Let's say we have 2, 4, 6, 8, and then again we have a record which is 100. So that 100 value is non-linear to the different records. So we call that 100 as outlier. So this is just an example, but how to find the outliers, what are the various techniques to find the outlier in our data set, and how we remove them. So this is the third option. Then we come to the normalization and scaling. What is normalization? Normalization basically a technique. Let's say we have a data in all the numeric columns. We have different scales of values. Let's say one column is having amount in dollar, and one column is having height in centimeter. Let's say one column is having height in inches. So these are the different scales for calculating the numeric values. So how to standardize our data set so that we can give a similar scale to all numeric values. So that is about normalization and scaling. Why it is important and how to do that, we will be discussing that later. Then further, encoding categorical variables. So what is categorical variable? Categorical variable is simply like an object or a string in which we have multiple classes or categories. So when you build machine learning model, so you cannot pass any data as a text. We have to convert that as a binary. So in case we have categorical column, how to encode them? And encoding is really important, and that's one of the important part of EDA or the exploratory data analysis. Then we come to the next technique, which is bivariate analysis. Bivariate analysis is basically analysis when we analyze two categories or two features all together, and we understand what are the relation between each of them. So that is bivariate analysis. So I'll be discussing each and every one in detail. data. So missing data we need to handle in different data types. So we have, for example, we have categorical data and we have numerical data. So we have missing value in both. You can see this is missing and this is missing. So how to fill this missing value when the data is categorical? So let's say you see we have 4 categories here. One is HR, sales, finance and testing. So we need to fill this missing record. So how you will fill this? We cannot apply mean, median here in categorical because we cannot perform a statistic summary on categories or categorical variable. So how we will fill this? So you simply think this, that we need to fill this value. So we need to understand what is the frequent occurrence of a particular record. What is most frequently occurring class into this categorical column? So you see the most frequently occurring class is HR. This is 1, 2, 3. It has occurred 3 times into this, and we see sales is 2 times, finance is 1 time and testing is 1 time only. So we will be handle this missing record using the most frequent occurrence of a particular record which is coming under that categorical column. So how we will fill this? We'll fill this using a HR. So how you calculate that? You simply, how to get the most frequent value into a categorical column? We have mode for that purpose. So the mode for this would be HR. So we have covered and we have handled that missing value using a most frequently occurring record. So it's clear to you how to handle a categorical missing? You can fill this using most frequently occurring record. And the same way, if we have missing record into the numerical column, you see that we have some random data records here, 2, 4, 6, 8. So these are linear. There are no variance, a lot of variance into the different records we can see here, means there is no outlier. So how we will be filling that? First we have to calculate the mean of that data, and how, when we use mean, in case we do not have outlier in data. So we can clearly see that there is no outlier in our data, just 2, 4, 6, 8, 3, 4 and 8. These are the linear values, no outlier into this. I will be explaining you with outlier as well. So we calculate the mean with this. So you simply add the all values 2, 4, 6, 8, 2, 4, 3, 8 and then divide by the number of occurrences. And let's say you will be getting mean something like this, 4.6. So you simply fill this missing record using a mean of this column. Now in a different example, let's say we have 80 in place of 8, something like this, and we need to fill this missing record. So is it a better choice to fill this using mean? Let's try to calculate the mean of this option. If you calculate the mean, it will come around 13.6 something. So you see, this is the mean value, this is the average value that we are going to fill into this record. And you see the records which are already there, that there is quite a variation between these two records. There is 2 and there is 13.6. So when we have outlier in our data, then mean is not the better option. Mean is not the good choice. Then what we are going to use to fill this? We will be calculating the median. So how to calculate the median? You simply sort all the records either in increasing order or in decreasing order, and then you calculate the median of this. So the median of this column with this outlier will be something like around 4 point something, 4.2 or whatsoever. This is just an example. So you see, in this case median is the better option. Median is the good choice. So just to repeat this again, in case we have missing in categorical, we are going to fill that using most frequently occurring record. And how to calculate that? Using mode. So using mode, you fill that missing record into categorical column. In numerical column, if we have data in a linear way, no outlier, then you can use mean. In case we have outlier in our data, then median is the best choice. And sometimes let's say we have lot of missing records into this. only one or two non-missing values there, then better to drop that column. It will totally depend on your data set. Let's say we have missing more than 90%, then we'll drop that column. Or we need to check correspondence columns as well. I'll be showing you using Python that those particular examples. So this is the part how to handle missing records in a multiple data types.
So guys, let's try this using Python. So we are going to use a data set, and the name of that data set is car data set that belongs to the information related to the automobile industry. So we are going to cover all these topics: handling missing, removing duplicates, outlier treatment, normalization and scaling, encoding categorical variables, and bivariate analysis one by one. So to start with, first we need to import the necessary libraries to perform this. So I'm going to import all the libraries, the Pandas, NumPy, Matplotlib, and Seaborn. Then I'm going to load my data and the data to my local system, and that's an Excel file. So I have loaded that. Here is the data. You see multiple columns are here. So I'll be exploring this data using some of the techniques that I have already covered. Let me try this again. And then the shape of the data. So the shape of the data, so that we can check the total number of rows and columns, and we see we have 303 index or the rows in our data set, and 13 columns are there. And then we are going to apply the info so that we can get an idea of our data, that what number of data types are there, and what are the name of your columns, and what are the total records in correspondence to each and every column. Here also you can get the idea there are a lot of missing records in these columns, because the total number of rows are 303, and we can see less than 303 values here for the correspondence of each and every column. We see 260, so there are also missing records. 297. Apart from 303, we have missing records in every column. That's what we can see here. So we are going to deal with this situation, and then we applied a isNull function using sum. What isNull does, isNull basically is to check the missing in that particular data frame, and then we use sum function with isNull so that we can get the count of those missings as well. In case you do not apply sum function, so it will give you output something in the form of boolean, true and false. So better you apply a sum function so that we can check the total number of missing records correspondence to each and every column, and we can get the idea of missing records. Now I'll be talking about how and what are the different options to deal with missing records. First is we can drop the missing values in case we have very few non-missing records, lot of missing values in our column, let's say more than 95%. So better we drop that column, and we can impute the missing values using mean and median as well. In case we have outlier in our data, so we'll be using median in place of mean, and in case we do not have outlier, then we can apply mean as well. Apart from this, if our data is categorical, then we use mode to handle that, mode to fill that missing record. So we are going to apply this here. So what we have did, first we have checked that how many columns are there in which we have missing records, and we need to check the data type of those columns so that we can get the idea that we need to fill that using mode in case that column is categorical, and in case that column is numerical, so we need to fill that mean or median. So I have applied a syntax here. This syntax from here to here, this is just to get the total number of missing in each and every column. Then I have applied a condition here. In case we have missing more than 0, then we have fetched the index and data type of those all columns. So here we can check that, and we see that multiple categorical columns, the object represent the categories or the string columns you can say, and float is for the numerical one. So we can we can select the categorical and numerical from here and apply the techniques which we need to apply for categorical and for numeric as well. So now what we are going to do here, we are going to replace null values in numerical columns using median. I am trying to apply median in place of mean. In case, see, in case we are going to apply direct mean. So first we need to check that in either we have outlier in our data or not. In case we have outlier, we do not prefer to apply mean. So just to overcome that situation, I have selected median to apply on this. So I have selected all the numeric columns here: income, travel time, miles clocked, car age, postal code. And I'm calculating the median of each and every record. Here you can see that. From this syntax, what we are going to apply, we are calculating the mean. I can show you median. I can show you how you can do that. And you can see from here as well. So it will give you output something like this. Then I'm storing that to median 1, median 2, 3, 4, and 5. For all 5 numeric columns, I have calculated the median and stored to median 1, 2, 3, and 5. And then I'm going to replace missing using this median value. So I have applied here, and you let me go through with the syntax. Car underscore df, that is the name of my data frame. Income is the name of my column in which I'm going to replace nan using median. So I have put it replace function, and replace we need to pass 2 arguments. First is for the for which value you are going to replace, and what is the value that going to be replace that previous one. So I'm going to replace np.nan. What is np.nan? Nan. np.nan is missing for Python. Whatever you have as a missing in Python, that is represented by np.nan. So I'm going to replace this using median 1. So this is the median one which we had calculated for income column, and I have put it in place equals to true. Why I have put it in place equals to true? What is the mean of that? See, in case you actually want to make changes to your master data, then you have to use in place equals to true, because in place equals to false is the default option. In case you don't apply in place equals to true here, this is not going to be change your master data. So that's why we have to use in place equals to true. Then I have applied the same thing for a different column, which is travel time. And the median of travel time I have stored into this median 2. So I'm going to replace travel time using median 2 and put it in place true here. And for miles clocked as well, and miles clocked median was stored into median 3. So I have replaced np.nan of miles clocked from median 3. And then for car age also have replaced using median 4 and postal code median 5. So I have replaced all the missing records here in this syntax. First I have calculated the median because I just wanted to show you how to calculate that, and then I have used the replace function. I can apply I could have create a user defined function for that part also, but I just wanted to show you step by step. That's why I have done this part. So I believe it's clear to you that I have replaced all the missing using the median of each and every column. Now we are going to tackle with the categorical missing records. So here we can see that these are the categorical columns. So I have calculated the mode of each and every columns here, and might be you are confused with why we are using values here. See, if you calculate the mode, let me show you here something like this. So you get output in this way, but I don't need this index. I only need value. I'm going to fill the missing using value only. I don't want to apply that index. So that's why I have put it dot values and the 0 index for that. So it will give me this value of that particular column's mode. That's why I have used values. Clear? In case you don't use value, so it will calculate mode in this way, and I'm not going to utilize index and values both. I'll be using only value part. So I have already selected that values part like this. So this is what I need to fill the records. Fine. So I have calculated mode and fetch the value for each and every categorical column. That's what you can see, and store that one by one from mode 1 to mode 7. We have 7 categorical column here with missing records. So stored, calculated mode and stored to mode 1 and mode 7 for each and every column. Then I'm going to use the same replace function to replace missing using mode, and that's what we did here in this syntax. You see, we have replaced all the categorical column using their mode. First we have calculated the mode, and then we have applied the replace function, quite similar to the median part that we did for the numerical column. Same we are going to apply here using mode. So we are done with this part. Let me run this code. Now, just to be sure, we again check either we do have missing or we removed all the missing from our data set. So let me try again with is null and sum function. Let me run this part. I haven't run this. This is here. I have run this and then this, and I'm going to apply this, and you see that there is no missing in these columns. All missing has been handled because we have is null dot sum as 0. So no missing into our data. So that's how we have handled the missing record from this particular data set. In our next video, we are going to cover the remaining topics. Meanwhile, keep exploring. Thank you guys. Take care.